Okay, in order to start, we need some silence, please. Okay, that was quick. Thank you so much. Welcome, hackers, to the closing ceremony of HackUPC 2026. During these 36 hours, we've done so much things. We're going to highlight some of the best moments. First of all of you have been hacking for 36 hours nonstop, and here's a picture of it.
You also have been enjoying all of the snacks of the cafeteria.
And of course, you've been eating all of our food. We're really sorry about the queues, but I think it was really worth it.
You also enjoyed all the midnight snacks.
And of course, you've played a lot of activities. Thank you so much for participating in all of them. They were really, really, really an exciting thing to do. And of course,
a special mention to the karaoke improvise that you did in the cafeteria. We loved it.
So before we begin with everything, we would like to thank again to all of our staff team, our organizers, our volunteers, and all of them are the ones that are making this possible. Without them, this weekend wouldn't have been possible because there's a lot of things to do. So thank you so much. I know that you are watching us through the live, so please, a big round of applause for them.
Next up, we also want to thank again the schools of our university and UPC for the help throughout the years.
And of course, we would like to do another big round of applause for all of our partners who have made possible to have the cafeteria filled with all the food. So.
Now, we want to introduce you the final judges, the ones who will decide the prizes of HackUPC judging.
So, sitting on the front row, we have René Serral, and we have Rael Garcia.
And we also have Oscar Romero and Conchi Perez. Thank you all for being here.
So now, let's begin with the most important thing of this closing ceremony, the finalist demos.
Come up to the stage, Blender, Blender, please.
Sí, sí.
Hola, hola.
Sí, ya está.
O sea, ¿sabes? Si lo pruebo, ya está.
Espera, espera. ¿Sí?
Vale. Pues nos podemos por el...
Venga, pero si luego hay que preguntarle o qué.
Vale, bueno, venimos aquí, probamos.
Vale.
Voilà.
Did you know that 58% of the time you spend coding is actually spent understanding the code that you're writing? We've all been there, right? Having to fix on a bigger project that someone has been working on, maybe adding features, fixing bugs, and you spend most of the time reading thousands of lines of code that you don't even know what they do, you don't know what function does what thing, and it's just a mess. That is what we wanted to fix with our project, Blender Blender. Basically, our project is a graph that localizes and visually shows what each function in a big project does.
The idea is that when we enter in a new project, we don't understand the things. So in this way, we can understand the different files, different functions, different relationships in a way of organization, and have an artificial intelligence agent that helps us to navigate through this. For example, Bruno will ask, we need to put the permissions, but Bruno will ask,
what does this project do?
and if the sound works,
This project appears to be a web application with AI-driven navigation and visualization
the idea is
features.
that
Key components include
if, for example, we want to move to another one, we can.
Would you like to
Can you show me what file generates the map?
The file that generates the map is likely lib/aimap.ts.
The artificial
This
intelligence
file
agent
has direct connections to visualization logic and API.
detects that we are asking to a node, so it localizes the node that is this function, and also detects that we are asking to see the code, so it has an implementation with IntelliJ, so it opens the file we were asking for. Also, we have other implementations about visualization. For example, here we can see different information. For example, security, what this means. If we are in a project with a lot of people, if a new person enters the project, if this person have access to different files, it can be a problem. So if this like manage what access do you have to different files. But if, for example, we have here a pen drive, a ledger, this is a pen drive that manage access to different files. So when we
Access granted. Access granted.
we put the pen drive here, the project detects that we have access and manage the access to all the files. Also, we have other information. For example, we can see what are the files with more length. Here we have the legend for understanding. And also for understanding the different files, we have a local AI, that here makes a documentation in real time. This is working on our computer. The idea is that if we want to understand the code, but we don't want to share our code with third-party providers like OpenAI or Gemini, we are like understanding this code in our machine. And finally, we did an implementation with Juni, that is like Cloud Code or the agent of IntelliJ, JetBrains. And we are going to do the last demo.
Can you add comments to the file that creates the map?
And
I'll add comments to the map generation file. This will help clarify the AI-driven mapping logic and its connections to visualization components.
So here we can see that it's connecting with Juni. Our artificial intelligence made a prompt that it's like it's a prompt that performs the use of this tool. And the idea is that now this Juni is editing the code. And a fun thing is that we are editing his own code. So our artificial intelligence is like programming himself, but because we are like seeing his own code. And if we go here to, for example, here we have the comments that the new system adds.
And also, lastly, whenever you select a node, we have a local model of Gemma 4 that briefly summarizes what that node does and all the functions within it. And it's all local, so that if you're working with sensitive data, you avoid risking leaks or or any fraud.
Yes.
And that's it.
Thank you. Hello? Vendor Blender team. The first question for you is, well, thanks for the presentation, therefore, but what did you learn with this project? Share with us.
Different things. Firstly, we didn't, literally this was a prize of another hackathon, and we didn't try to use this well, anywhere. So it's the first time we try of using a type of pendrive like this. Another thing we learned was to use local AI in a computer. This is like a state-of-the-art model because Gemma 4, I think that is new of around some weeks, I think. And it's also optimization because we have like a really fast inference in generating the voice. We did some optimizations to generate the voice like in streaming. So you are listening the voice when the entire audio is not generated at the moment. So you are like listening the first word, but the last word of the phrase is not generated in that moment because it's for fastest listening. So they are the main things.
Thank you, guys. A very interesting project. One question. Would it make sense for you to understand the Git history, for example? I think it would be...
Yes, we have a Git activity option. You can see like for example, the files that have more Git activity. For example, if a file have a lot of Git activity, means that the entire group of the project is working a lot with this file. Also, if we maintain preset bubble of this, the program generates another bubbles that are like related, and these bubbles are saved inside the Git. So if a person saves this with a commit, the other persons of the team have like the same graph.
Yeah, well, my point was if you would be able to, for example, go back in history and to say, hey, the problem of, I mean, we have a bug here, so going back and pinpoint what was the problem.
Yes, because this is like generated from the code. So if you go to a code that from 3 weeks ago, you get another graph, but it's like the same for that moment.
Thank you.
Okay, so now let's welcome to the stage the group Mirror.
Actually, when I managed to get a hole in between the dependencies, probably. It's moving. I mean, we can just keep it like. Okay, can you keep it like this? Okay, can you keep it like this? Right, don't touch it. Right, just change it. Just doing it. What?
How things working? Oh yeah, looks okay. It looks okay. How things working? Okay, someone needs to figure out how to control. You need to figure out how to control because it's only extended. It's not showing on that.
Yeah.
So, okay, don't resume now. Okay, wait. Are they familiar with the tracks? Do they know about the tracks, the judges, or do we have to explain the tracks?
Yes, no, they do.
Okay.
Okay, you have the mic?
Is it on?
Don't worry about it.
I'm assuming you're all familiar with the track, so I'll just get started on what we did. Alex, the first night, he spent all his time building the model of the 3D printer that we were given. As you can see, these are all the components of the 3D printer. We built models here. There's a temperature and humidity plus volume up here. Now, the humidity is completely affected by printer usage because of fluid in the system. Do you want to start the demo? There you go. As you can see, if you look over here, you can see the degradation of the system. We built models to show how the mechanics of the system degrade over time. As you can see, when the day count goes up, you can see the health of the system. Alex?
Yeah, okay, so as you can see here, we got the components which we're supposed to be modeling. You can see the status here, which at certain health percents would change. And you can see the actual health bars here. If you look at the actual diagram, so for example, the recoater blade would correlate to the recoater blade in the diagram here. And so if one presses, if you like press this, if you just click, then it will highlight down here what component you're on. So then you can actually see, oh, okay, the component I clicked, this is how much health it has left. And if we run the simulation, if you continue running it, if we can, please. Oh, sorry, no, fast forward, sorry. That'll be better. Okay, and as you can see, it gets into critical statuses. And if we keep on running it, can you fast forward it, please? Yeah, click a few more times. Yeah, okay, and then as you can see, okay, as soon as it reaches 30%, that's when we would consider, for example, the cleaning and thermal interface degraded to the point where we can't use, which would classify as a failure. And at that point, we would pause the graph here. So you have two other options. You can rather continue the simulation in case you want to continue modeling and perhaps looking at the rest of the degradation of the other components, or you can just stop it right there. And then after we pause the simulation, it will then get sent to a CSV file in which then you can use this data, gather it, and then make plans and methods to continue modeling more better and refined models. Yeah, and for the, we used different types of algorithms to program each of these different types of components. For example, the recoater blade, we use something called the R-card abrasion formula, which has something called, has a constant called K, which is a wear coefficient. And part of this wear coefficient, there's something there's a contamination variable. And we've basically used noise to randomly select some similar within a range of contamination values. So because in a normal real-world scenario, you wouldn't just have a static base value. It's always going to change due to random stuff you can't actually avoid. So every single day, as we can see here, here's the day, and it will pause whenever status is failed. And then you can see what day it roughly fails. And then because we added noise to this, these components won't fail always on the same day. And I think that's it from me.
Okay, so first of all, congratulations, very nice demo. I have a question about the models or the formulas that you are using behind the scene. So what is your background and how easy it was to, for example, find the right formula for heating, and how did you fine-tune it into models that just evolve with time?
So for our background, we're computer science students, first years at the University of Southampton. And most of the models we found by scraping research papers. So just looking at what different professors or researchers or industry specialists made to model hardware degradation or thermals. These two are the ones who actually figured out what models. So do you want to add to it?
Right. So one of the models, an example for insulation, we used Fickian diffusion as a model. It's a differential equation. So essentially look how thermal humidity affects the insulation panels. So as the temperature changes over time, very, very minor changes, you see micro fissures and cracks appear on the insulation, which over time will compromise the effectiveness of the insulation.
But with every single model, everything else affects it. So temperature can affect the nozzle, let's say. And in every single equation we used, there's one variable inside, at least one, of every other component. So one thing affects the other, that affects this, and it's like a chain almost. Any other questions?
Yeah, I have a question. How do you plan to integrate live metrics from the real printer into your models? Or because the computational model is always be the same based on the environment, but a real machine will behave differently because there are way too many variables in the environment in order to make a model. How do you integrate these real world metrics into your model so it can evolve?
Yeah, so basically we mostly just looked online for similar industry standard 3D printers. And because obviously we don't have previous historical data, we have to just give our best guesses of realistically how long this would last, compared to similar things based on the material. For example, depending on what material, depends on the hardness, which changes how much it would degrade by, for example, if that's the question.
But the model in the future will be able to fed from live metrics from the actual machine instead of like betting on paper data, like current status of the actual machine, current temperature of each component, current like if the plate that you said before has like some degradation. That can the model fit onto from real live data, not like only the base one that you use for the base model? How the model evolve with real data?
Yeah, that's a good question. So some of our formulas, or most of our formulas, the variables can be changed. For example, material hardness or density. You can look at real data, and then you can look at what's similar and different between different 3D printers, and then you could narrow down, say, well, clearly here the difference between these two formulas, well, the formula is the same, but in different printers, would be the material hardness. And then you can try it with the data and the simulation, and it would show a difference, a tangible difference. So that's what you'd have to do.
Sorry, does that answer your question? Yeah. I didn't feel like it did. Yeah. It wouldn't be, it's not like a one size fits all, right? This was built specifically for a HP model. Like, we were given one model. Sorry? I'm not sure. But if we were to like apply it to a different machine, we would have to.
You have like a lot of metrics that get exported from the machine. Like machine probably self-reports the temperature of the system. It self-reports the number of runs that it did. So all this information is from the machine. Can that information be used in the model? So the exported metrics from the real machine?
We would have to modify it. For example, for the recoater blade, you can actually, there's a formula you can use to actually like measure, for example, because this is purely theoretical, we've just given like a static value for that, like the hardness of the recoater blade material, because different, you can actually use real-world application by actually taking the recoater blade and measuring the hardness of it, and then you can actually input it into this app to actually simulate real outcomes with that new printer. That's what you mean?
That was amazing, guys. Thank you so much.
I'm like really.
Thank you, guys. All right. And next up, please welcome ConvertFS.
Like this.
Thank you so much. Hello, everyone. We have developed ConvertFS. So a lot of people in this room have probably been in the situation where you've got an image and you need it in a particular format, or you've got a video that's just a bit too large to upload to Discord or something else. So off you go to the browser and you type in video compressor online, or you type in PNG to JPEG or something like that, and you have to upload your files, convert it, and download them. Or if you're more tech savvy, you can go and pull up FFmpeg and type out a monstrous shell command that fits, like, that wraps around 3 times on your screen or something. We thought that kind of sucked, so we developed ConvertFS, which is a file system in user space. For people who haven't used that before, it's essentially like a virtual hard drive. So here I've got a PDF, a JPEG, and an MP4 to demo this. I am now going to run, ConvertFS. Let's call it HackUPC. And you'll see that over here, there now appears a new virtual drive. What I can do with this is, currently it's empty, but I can drag in, for example, this JPEG, and it gives it to me in a whole bunch of formats. So I can say, OK, I want a PNG, and drag that back out. And you can just convert from any format to any other arbitrary set of other formats. Or for further examples, let's say you've got a PDF and you want to turn that into Markdown, for example, to paste into your Notes app, or maybe you want to feed it to an LLM. You can get the Markdown here. And just to demonstrate that this is an actual file system that you can interact with, I'm now going to try and open that file up. And there you can see, that is this PDF document over here, converted into Markdown. And as one final demo of this, let's get rid of that. Sorry, it's hard to use a microphone and also type on a keyboard. I'm now going to pop in this recording. This here is just a video recording of my desktop at 4K. Let's say I want it in a lower quality. I can go into quality here and choose a different quality preset, change a preset for YouTube uploading, or maybe I can choose a resolution like 240p. And you'll notice down here, currently, it says 0 bytes. There is nothing on the disk. All of this is computed dynamically at runtime. It's lazy loaded. I drag that out, and it's going to take a second to do the conversion. And there is the same video in a lower quality now. And of course, because we're all of us 3 are computer scientists, we want something hackable. So all of this is completely modular. You can completely configure it in Python. One example of this is that over here, I have got an example calculator.py. I take in a calculator file, I put out an answer file, and I just evaluate a maths expression. So what I can do is I can go here. I'm going to put the microphone down and just let the screen speak for itself. Bill. So yes, this is ConvertFS. It is a hackable system for converting arbitrary files. You can use it to compile source code. You can use it to convert between file formats, transcribe audio, feed input into LLMs, whatever you really want. It all runs on your local machine, and it's lazily evaluated.
Thank you for the presentation. Very, very interesting. Come on, guys. Thank you. One question. I guess that you're using Fmpeg in the background, right? Or any other system to convert. So it's a requisite to have the application installed, right, into the system.
Yes, so we are currently using FFmpeg as one of multiple converter backends. It's entirely modular, so you can install them individually separately, choose whatever you want. If I go to the console at the top, you'll see that it's automatically discovering converters depending on what you have installed. So you can pick and choose what features you want.
Great. As an addition, I would put a progress bar of the compression, because I mean the conversion, because if it takes too much time, you know. But very nice, thank you.
Yes, we do not have file streaming implemented, mainly because this is our first time using Fuse, and file streaming is horrible on Linux to figure out. But yes, that is very much something we want to do.
Yeah, very nice, thank you.
Thank you so much. Perfect.
¿Dónde está Gabriel?
Okay, so now please welcome to the stage Pairs Up.
Okay, so Tinder, Bumble, and Grindr, what do they have in common? Well, they store and they train with your data while they share it with third parties too. For this reason, we present you Pairs Up, our decentralized dating app that uses distributed federated learning for its recommending system. Aaron, please.
So let's see a bit of the demo. And here I present you PeerUp. This is sponsored from the Peer. Well, it's from the Peer Challenge, and that is why the name of PeerUp. And as you can see, it's very similar to Tinder or Grindr. I don't know if you have been there, but you can basically like by switching right or pass by switching left. And you can decide which peer is your other half. So here you can also edit your profile. And whenever you do a match, oh, it seems that I did a perfect match. Here it is. Oh, it's Pearson. Pearson is saying, hello, you lovely lemon pie. Oh, hi. Well, before anyone is scared, Pearson is my friend Mark here, and we are chatting via a peer-to-peer decentralized chat, also done with the help of peer libraries, and we can do it in real time with no latency, as you can see. But the real problem here is, okay, how to find my other half? So here I have an 85% match, not bad, but how is this percentage calculated?
So basically what we did is we wanted to also keep the recommended model private, obviously. So what we did, we recurred to decentralized federated learning, which basically means that you have like edge models on each device. It's a very simple model, obviously. But what you can do is you run training on your local device, and then you update globally to the global model in order to have the strength of a generalist model. By sharing your weight updates. Then you do a federated averaging, and you get, via broadcast and this federated averaging, like a general performance model, but without sharing your private data.
So since you need to have a little bit of data to train these models, and we cannot manually generate it ourselves, just being like 4 hours doing clicks, we did a simulation just to, like, for example, say if we have 16 peers that are making optimal decisions based on their preference. So for example, if you're a dog lover, you will be likely to give a positive match, well, swipe to the right? Is that right? Well, yeah. To other cat lover, other dog lover persons instead of cat lover persons. And well, just to be clear, this is a way of not training the model in a centralized way, because basically what you don't share the data, you share the model weight. So it's like kind of an encrypted, clever way of making this work.
So what you're looking right now is just a silly experiment. Obviously, we have very few peers, and the data is very low, so the thing is going to be very noisy and not much to learn, obviously. But a little bit can be, and what you're seeing right here is the difference between the weights of a local peer and the aggregation, obviously zero difference, otherwise it wouldn't be a good aggregation, when it happens. So the last point is the training point on the local model. As you can see, it goes one step ahead, and then when it syncs with the other peers, it goes to zero. What we want to see is, in the long run, to see these model weights converge into ideally the same model. Okay, thank you very much. That was all.
Hello. Yeah. So first of all, thank you for the demo. What is your background, and how familiar you were with training decentralized models, especially federated learning? Have you done this before? This was your first time?
Well, our background is in AI. We work at the CUPC, and we don't know much about distributed or peer-to-peer protocols. So for us, all of that was pretty hard. And the federated learning part, while we haven't never done that, unless in a distributed way, that it's not the normal way to do federated learning, wasn't the hardest part for us. For us was all these CSS, HTML, JavaScript. This works with Electron and all of these things that for us is like pretty new. We know Python.
So a system like this is like very easy to attack. There are very similar like attacking vectors. How do you are planning to mitigate this kind of inference from users or bad actors?
Well, actually, the dirty part here, that is the peer-to-peer protocol, it's supposed to be handled by the peer itself. That is the framework on top of all of these works. And it uses, as far as I understand, I'm not an expert, I think you have the experts like a couple of rows behind you. But it works in a public-private key, so whenever you encrypt your messages, they are encrypted with your private key, and then the persons that you talk to, they use your public key to disencrypt them. So it's just peer-to-peer connections.
And now, last but not least, Smadex Creative Copilot. Please come up to the stage.
Okay. Hello. Yeah, so our product basically is like a solution for ad companies to like know what's working and what's not, and like to create new ads. So basically, we have divided in analytics, like to see what you currently have, how it's working, and then like generating to like generate new ads and that work well. Here in the first page, you see like a broad distribution, and you have the top performers here down. So you can just also like click on any of the creatives, which are the ads, and you will see like first the image, then also some analytics, so information. We also have used image features with like Peel, like extracting like colorfulness, brightness, stuff like that, to see similar images. And then finally, we have an AI button to explain why it performed well. This is like a Gemini wrapper, but it's not like just prompting to Gemini, but rather we have used machine learning on the background to train a model, and then we have passed SHAP values. In case you're not familiar with it, SHAP values basically mean towards maximizing a predictor, what features are actually mattering the most, what features drive this predictor, and SHAP values capture that. So basically, we pass these SHAP values to Gemini so that it can understand what's actually like, it can know mathematically what's actually working and what's not, and what's driving that predictor, and then it explains it in a human way. Then actually, we can see like in ML Insights, we can see also, ML Insights, 1 second. ML Insights in the top, yeah. No, Machine Learning Insights, the fourth tab. The fourth tab, Machine Learning Insights. Wait 1 second, yeah. Yeah, here we can see the weights of each like feature for different metrics, and we can also see like the fatigue now. Yeah, the fatigue tab to see which ads are now already wasted. They are not performing well. More time, they have already wasted the potential. And then finally, we have divided in clusters to see like similar type of ads in different 8 clusters. We have also like categorized them with SHAP values and AI, and you can use AI to explain it in an add-on below. And then finally, I'm going to jump to the generative part. You have two different things. The portfolio optimizer, basically you can put it current ads that you have, and then this slider is to choose whether you want to optimize for diversity. So choose an ad that is orthogonal to what you currently have and more different, or just like focus on what you already have and making it work better. And yeah, basically AI also can explain that with SHAP values, like the same as before. So you can like
depending on what you want. And finally, the predictive creative. The predictive creative, you have like all these values. There are 2 that are required, and the rest of them you can leave it blank, and AI will autofill them with the best values that we have found with our machine learning, so that you can produce the best ad at all. So it autofills them. It suggests here. It will tell you how it perform, and then in this, well, it also explained it. And then in these 3 features here, you can see like similar ads that we have found to yours, so you can actually see how they look like, how they did, there is historical data, and all that stuff. So yeah, but that's basically the model. And then we also have in recommendations as well, maybe in the analytics part, we have like some, what should you do with the ones you currently have? Should you pause it? Should you scale it? Should you monitor them? So yeah, I think that's a bit of a broad overview of the project, because I don't know how much time I have. Yeah, but it's probably over, yeah? Right.
Hello. Okay, thanks for the project, very interesting. And let me ask, you are the 2 persons working on that. What is your knowledge about all the ads world? Because this is a complex world also. And what has been the challenge for you to prepare this product?
Do you want to answer? I mean, we didn't know anything about that, just like the ones that pop up to us. But I think to us, we just saw it kind of like data set. We didn't care that much about like the reason behind it. We cared for the orthogonal part, which we did before, because I mean, you want it to be orthogonal, but you also care like if you are doing, I don't know, fintech ads or entertainment ads. Probably if you go to like, I don't know, gaming industry, it will be very orthogonal, but that doesn't interest you, right? So we only cared in some like specific aspects. Otherwise, they are like vectors of data, which we use to feed machine learning. And I think we didn't need much knowledge about how ads work or ad tech in general.
Okay.
Just a quick question. So how did you decide the metrics that you are using here and which one, the ones that were better for your purpose?
Okay. Basically, the metrics, we were already given some. Like there are some specific ones for ads that were actually in the Excel. So like click-through rate, so how many clicks per views, how many conversions per views, how many ad spend on conversion, like a lot of those. We mainly use those. And then we basically let the user, because this is basically a solution for a user, for a company, for an ad company. We let them decide what's their goal. So we show different performance, like we show different metrics depending on what they choose. They can choose the metric they want to maximize. They can like see data for every metric. So basically we have like the 4 more important ones, like which are like the 4 that were given to us, and they can choose between any of those 4 to choose those metrics. Yeah, basically.
So now we have all of the demos for the HackUPC prizes. While the judges are deciding the ones that are going to win HackUPC, we're going to start with the sponsorship prizes. So please, let's start with
Mecalux, welcome to the stage. ¿Un micro?
Los ganadores los tenemos en un papel. Bueno, lo tengo aquí. Vale, ¿pero lo sacamos ya o...?
Lo sacamos nosotros.
Ah, vale, aún no.
Sí, tranquilo.
¿Pero lo digo ya el tercero y tal o no? Hello. So the third prize, which is a U-Green charger, is for Isolizer. Se llamaban así. Isolizer. Hay que hacerse foto, ¿no?
And the second place winners for our challenge and winners of 4 Raspberry Pi 5s are for Baymaxing.
¿Los ha apagado?
No,
Sí.
Después de dar el
Finally, the first prize that it's for Nintendo Switch 2 goes for Carvasot. Finally, we want to thank to all the participants. It's been a really difficult decision, and we want to make 2 honorific mentions. One is for Warehouse OS, that it was really close for them to enter. And the other one, it goes for Below. They were only two people group, and they make a really impressive visualization. So congratulations to both of you.
Thank you so much to everyone. Now, let's welcome to the stage Purse for the prizes.
Well, thank you. So first of all, saying that I wish we could have more than one winner because I've seen like so many amazing projects. So props to you guys. Thank you very much. Our prize is 4 Barcelona jerseys signed, and the winner is Biomesh.
Thank you, Pers, and congratulations, guys. Next up, bending spoons.
Hello, everyone. We're the Bending Spoons team. It's such a pleasure to be here. First, before anything, we wanted to thank the organizers. The event has been such a blast, and it would have not been possible without you guys. So thank you very much. Also, to the hackers, it was lovely being able to speak with every one of you at our booth, being able to talk to you a little bit about what we do at Bending Spoons, and of course, see your submissions. Speaking about submissions, we got a bunch of them, and they were all very, very cool. We spent a very long time trying to deliberate and choose. Unfortunately, we can only have one winner. And so congratulate me in thanking the winner of the Bending Spoons Challenge and of a DJI 3 mini drone, Slap.
And now we're going to continue with the prizes for the challenge from HP.
Hola. 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 ¿Sí? Hello. Thank you very much. First, let me say thank you to the organization and the two Marias who has been doing an amazing job, right? Also, let me thank you, the technical team who made the challenge possible. And thank you to the 11 brave teams that had the challenge, the courage to be presenting to the, I bet, the most difficult challenge that we presented. We made it especially difficult because we wanted to get the teams that really are brave in terms of solving something that is out of the box. We got 11 teams, one unique female, right? So all female teams, and more than half of them had mixed teams. So I really want to appreciate those that came with women in tech in our teams, right? So that's why I want to mention that. A big applause for that. And thank you. And then let me pass it to Martial, who will do a bit more words about how the teams were performing and what we valued out of the teams. Martial?
Just let me say very quickly, 36 hours ago, and just 36 hours ago, we presented a tough challenge. Many of you came to us and said, this is going to be tough. It was thought to be that way. We encourage you to surprise us, and you did that, and then some more. So please, a round of applause to all the teams that have participated, because you nailed it.
Amazing.
Just three things. These teams had to work through not having synthetic data to train. You have to work tough, really hard on the model. That was thought on purpose for you to have to think through, not just code, but also think. You did an amazing job. The second thing you had to go and ground AI to reality. So these teams had to make the AI work in the real world. That was a super challenge, and most of them, if not all, managed to do that. And finally, we set 3 stages. We thought the third stage, maybe some people don't get time. Almost everybody or everybody managed the 3 stages, though. That blew us off. I mean, amazing. And then some teams even did more. So excellent, excellent. Congratulations to all the participants. Thank you so much.
Thank you. Exactly. For coding, you have Codex, Cloud Code, and so on. For thinking how you match reality with coding, that's where we need humans, right? So just for everyone who participated has the awards of coming one day to HP, and they will have a guided visit, and they will see the 3D printing machine over there. So all the 11 teams will be invited through email, and will have the chance to visit our HP site in Sant Cugat. Okay? Second, we had a very, very tough time to decide the winners. We came prepared with two prizes, and we couldn't decide up, and so we decided to give a third award, a honor award that will only get a T-shirt, but we thought that it was worth to mention. It's a honor award, right? So that's one thing that we want to mention. And with that, let me go right to the third one, right, which is the Digital Copilot for HP MetalJet S100 by Oriol Ferrés, Arnau Noguer, Adam Serrate, and Sergi. Thank you. Second award is an HP Poly Voyager 2 headset, so a cool headset to kind of do remote conferences. And the prize goes to HPCP by Daniel Sticker, Jana Lowe, Leonie Grever, and someone else. The fourth name is? The fourth name is Daniel, Jana, Leonie, and Christina. And let's go to the winner, and the winning team will get an HP EliteBook 6G AI embedded, so it's an AI PC for each of the components. Now you realize why we created such a difficult challenge, because I think that the prize deserves. So they will get one computer per person, and the prize goes to HP JetSense by Dan Bansea, Carles Malé, and two more components. Dan Bansea, Carles Malé, and two other names which they will tell you. Dan, Carles, i els altres dos?
Òscar i Àlex.
Òscar and Àlex. Thank you. Congratulations. Gracias. That's all. Thank you very much.
Thank you so much, and congratulations, guys. Next up, Inditex Tech. Ahí. Sí. Espera, ¿está encendido? No, aquí. Ahí.
¿Sí? Hi, everyone. So, first of all, we would also like to thank the organization for such a wonderful opportunity we had this weekend. It's been an absolute pleasure for us guiding you all the different teams during this challenge. Okay, we are very amazed and proud of the results that you have managed to get. Okay, it has been a really difficult challenge sometimes, but you didn't, stop trying. That's very nice for you. Then not only have you understood perfectly the problem, but you have also presented some brilliant ideas, and ideas that can go into real production. So we are really proud. Well done, all of you. Okay. We only have one winner this year, okay? But Nico will present what is the prize.
Thank you. So our winners wins an AI compact computer that you can host your own models and your projects in the future. It has 8 GB of RAM, quad-core processor, and also an AI accelerator that can deliver up to 26 TOPs. So we will give one for each member of the winner group that my teammate announced now.
So please, a drum roll for the winners.
So the Inditex Tech Challenge winner is Silo Hacking. Please welcome to the stage Ada Pagés, Ana Aparicio, Ismael Pinto, and Alejandro Lorenzo. Welcome.
Okay. So next, please welcome to the stage Qualcomm.
Hello, everybody. So first of all, I want to really thank you, the whole organization. It's an amazing weekend. It's been fascinating to see how much innovation, how much is going on here at UPC. I wanted to thank also my colleagues who were here actually, coming from Italy, France, also Barcelona yesterday. Sorry that just me today, so you have to bear with me for now. Yeah, it's been really exciting, and for us, this is the first time we do this, so bear with us also with that, but we're really excited to be able to do this going forward. So looking forward to continue to talk with the organization and see how we can continue to partner. One of the reasons we were able to do this also is because maybe you learned recently that Qualcomm acquired Arduino. So what an amazing playground, what an amazing toy, right? So this is why we're so excited that we're able to come and provide the Arduinos and enable challenges. So we're doing this here in Barcelona, but also in other places in the US, UCSD, other places. Very excited to be here in Barcelona for this first time. So we're learning a lot, and bear with us with the logistics, but I think it's working pretty well. So I just wanted to tell you about the prices. I think that's what you guys really want to hear. So first, all of you who participated in the challenge, in the Arduino challenge, and presented, you can take it home with you. So for each of you, you can take the Arduino with you. So really, all of you are winners because I think you really deserve it. And then we have third, second, and first. For all of them, third, second, and first, you're going to go home also with a Rubik Pi, in addition to the Arduino. And then for the big winner, we're going to give you a laptop. It's with a very cutting-edge Snapdragon chip in it. So this is the chip that we produce. It's a new chip that allows you to do a lot of cool stuff, AI stuff. It comes with CPU, the GPU, but also NPU, neural processing unit, so that you can actually do some of this local AI stuff, right, that you actually have been also demonstrating. So looking forward to for you guys to enjoy that. So with that, let me just go through the list. And rank number 3rd, Guaita. Congrats. All right, exciting. So rank number 2, Festi Cleaner. Congrats. Well, one small thing I had to say. So they're on their way. The gifts are on their way, OK? You got the Arduinos with that work, but actually the tracking number, the ETA is for tomorrow. So bear with us again. So we'll ship the laptops and the rest of the hardware to all of you. And the very first winner is Jubrino. Congrats, guys. Thank you so much.
Thank you very much.
Right. Yeah. Perdona que
And now, next is Smadex.
Hola, hola. So, thank you everyone. Thank you, organizers. Thank you, hackers. It has been really, really tough. We received a lot of submissions. The guys have been discussing for more than 1 hour. They are already discussing yet because it has been tough to decide the winners. So, having said that, let me present directly. We have 2 prizes. The silver medal goes to Smadex Art Courtroom for Oscar, Guillermo, Laia, and Mohamed. There are some wireless gaming headsets for you. Felicitats. Felicitats. Felicitats.
Fotito, ¿no?
Que sort tenéis, ¿no? Vosaltres. També? Venga. Detrás. No, fiqueu-vos al mig, al mig. Al mig? Ah, no, ells. Sí, sí. So, thank you. As I said, it has been really, really difficult. Your level, it's crazy. This is the first time that Smadex participates, but we're looking forward for next edition because it has been astonishing the level of your work here. It's amazing. But the first winners, the best of the best of our challenge are Smadex Creative Lab, Joel, Michelangel, y José. Thank you, guys. La foto. Otros no s'ho ficat al final, cabrón. Thank you. I hope to see you all in the office soon.
So now, let's welcome to the stage JetBrains.
Two. Give us two.
Hello.
Okay. Yeah, it's on.
Hola. Hi, everyone. First of all, as most of you said, we also have to thank to the organizers. I, as a student in Serbia, was organizing similar events, not to this scale, but similar. And believe me, the work you see is only a little 1% from what they actually do. So big round of applause for them, once again. Also, congratulations to everybody. We had 28 teams, and all of you were so amazing. I don't know how the rest of the companies chose the actual winners because it's so hard. You all killed it. So please, when you came to us and you asked us, what do we want to see from your project, we told you that we want you to build something that you're proud of and that you, tomorrow, when you sit on your computer, you can open and use to better your performance, to enjoy your coding more. And I think all of you did that, which is the most important thing. So please, keep doing your stuff and keep enjoying your projects. So, without further ado, I'm going to let my colleague Susanna announce the prizes.
All of you and your projects were amazing, and we really value the effort that you put into this challenge. So yes, without any further ado, the third place prize goes to Bender Blender. Good job. You did so well, good job. Great, good job. Sorry. Oh, sorry. The second place prize goes to Drum roll, please. Open Planner. You did so well. Congratulations. 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 Muy bien hecho, chicos. Lo habéis hecho genial.
Muchas gracias.
Okay, last but not least, first prize, again, very, very difficult to choose, is a team. Drum roll, please. Arc React.
Next up, we will hear the prizes of Skyscanner.
Hey everyone. We are so thrilled that this hackathon happened. I'm closing a circle as well. I used to be an organizer myself here, now working at Skyscanner. And it was so difficult to choose a winner overall. So yeah, after careful deliberation, as well, I want to know, like all the people have been third and second, first place, you're invited to our offices here in Barcelona. If you can drop us a message and we can organize that. But yeah, so we have the third prize for Rome. Was one person, yeah. No, one of this. That's really nice. I have Indie Hacker. You're solo. Second prize goes to V2 Travel. The rest is the same. And no, this one's for the first. Yeah.
How many do we have? 1, 2, 3, 4?
4. 1, 2, 3, 4. Yeah. This is for this one. Right. Sorry. Thank you.
Very impressive demo. I really
Very
like
impressive demo. I like it. Yeah.
Congrats. Congrats, mate.
Alto. And the first prize goes to, was a last minute submission, just literally last minute when we closed everything, Peer Post. I guess they left. Peer Post. We'll make it sure they will receive it. Ah.
So, to end up with our sponsors, please welcome to the stage, MLH.
Thank you so much. I'd like to start with a huge round of applause for the Marias and all the other organizers for organizing such an amazing HackUPC. I'd also like to thank everyone else here, volunteers, sponsors, hackers, for making this event so special. HackUPC wouldn't be the same without you. I've had such a wonderful time seeing what everyone's made. It's been such a wonderful community, and it's been a pleasure to be here. Okay, I'm going to start off with my challenges. So, for the best domain name provided by GoDaddy Registry, winning $50 gift cards, it's Bender Blender with blenderblender.cooking. Nice, congratulations, Swapper. Congratulations, well done.
Thank you.
Well done. And now for the best use of Solana, winning some digital ledgers. This team used the time on smart contracts alongside other security tools to ensure the privacy of someone's data when they pass. It's last safe. Congratulations. Thank you so much. Very much. Very much. Very much. Well done. Well done. Well done. Good. You want to be in the middle? This way. Forwards. Forwards. Nice. Well done. Congratulations. And for our next prize, we've got Best Use of 11 Labs, winning some Beats Solo Bud earphones. And the team is B2 Travel. This team created a really good conversational agent that was alongside a VR environment that picked the best places to travel to.
Well done. Amazing
Thank
job.
you. Thank you very much.
Great project.
Thank you so much.
Well done.
Thank you.
Well done.
Thank you so much.
Thank you. Towards. Right here? Yeah? Okay. Amazing job.
For the next prize, best use of MongoDB Atlas, winning some Firestart IoT hardware kits, we've got Scrunkly Draw. This team used MongoDB Atlas to store vectors of brushstrokes in their wholesome social media app for artists.
Amazing job. Amazing job. This is for you. Well done. Thank you. Lovely project. Well done. Well done. Congratulations. Thank you. Amazing.
And for our last prize, best use of Gemma 4, winning some Google Swag kits, we've got Skyscanner. Or Skysgamer. This team used the game environment as a front end to give Gemma and use Gemma 4 tools to call the Skyscanner API.
Thank you. Thank you.
Amazing. Thank you so much. HackUPC has been so wonderful. It's been a pleasure to see all of your projects and walk around and talk to everyone. It's been a wonderful event. It's been a pleasure. Thank you so much for having me. I've been Oscar from MLH. We've also had Quinn and Erin. Thank you so much, and hope to see you at future hackathons. Happy hacking.
To finalize, Airbus and ThinkUPC didn't have a challenge, but we also want to thank them really much for participating and being a sponsor to our event.
So now let's start with HackUPC prizes.
Remember, you're all going to have a trophy, but apart from that,
the
on
third
their
prize goes to...
I'm going to have to look at it from the list I've gotten, let's hope. Smadex Creative Copilot.
Congrats. Felicidades.
Thank you, guys. Congratulations.
And the second prize goes to Pairs Up. Agafeu els ordinadors més. And now let's take a picture of together.
And for the last, the first place for HackUPC is ConvertTFS.
Congrats. Here you have.
Thank you. Thank you.
Let's go to take a picture together. Come here. Come closer, yeah.
Congratulations, guys. And now, to tell you the winners of the game are coming upstairs, Damien and Yao Yao in representation of the web dev team.
All right, so the game has ended. Thank you all for participating. It was a blast.
Okay, so before we know the winners, let's get one last drum roll. There we have the top 10 who will come. Please. Clar, com fem la talla.
¿Te salta L?
So, as we've been saying the whole weekend, if you post something on social media, Instagram, TikTok, whatever, please, 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 you can tag us in HackUPC, or you can use the hashtag HackUPC2026 so we can see your pictures.
Thank you so much for being at HackUPC, but we want to specialize one thing. This is only one of our events.
We are hackers at UPC, and we're doing so many events during the whole year in our university, the UPC. So if you want to follow us, we also have social media for hackers at UPC. And there's some interesting things that are coming, so stay tuned.
Thank you so much for coming, everyone.
Thank you.